Hello everyone, welcome to our channel Study Easy. In today's video, I am going to discuss the mathematic part of the question paper of Ed.CET 2024, 23rd May Shift 1. So the first question is, among the following a number that is not an irrational number. Options are, the first one is root 2, second is pi, third is 1.12, 112, 1112 and so on. And the fourth option is 1.36 bar. Before answering the question, let me explain you about rational and irrational numbers. So let us learn more about rational and irrational numbers. See here, 1, 2, 3, 4, so on. They can be written as 1 by 1, 2 by 1, 3 by 1 and 3 by 1, 4 by 1, so on. Okay, so it is nothing but P by Q form. Okay, so this is basic. Okay, now let us take one example as 1 by 2. Okay, if you divide 1 by 2, okay, 0, 0 0.5, 2 5s are 10, you get remainder as 0. You get remainder as 0 and quotient as 0 0.5. We got the remainder as 0 and the division has stopped. Now this is one example. We'll take one more example. 11 by 9. Okay, 11, 9. 9 ones are 9. 11 minus 9 is 2. Okay, so what we'll do, we'll keep a point here, we'll keep 0 here. 9 2s are 18. 20 minus 18 is again 2. Keep 0 here. 9 2s are 18. Again remainder is 2. So 9 2s are 18. Again there is a remainder of 2. So it's repeating. Our division is not getting terminated. It is non-terminating and the quotient is also repeating. Okay. So how can we write the quotient as 1.222 so on. So it can be written as 1.2 bar. Okay, bar over a number means that number is being repeated continuously, infinitely. Okay, so is it terminating? No, it's not terminating. It's not stopping, right? Hence it's called as non-terminating. What it is called as? Non-terminating. Non-terminating. And is it repeating? Yes, it's repeating. So it's non-terminating and repeating. Whereas in the first case, you can see, is it terminating? Yes, it has terminated. So we can say this as what? Terminating. These decimals are terminating and these decimals are non-terminating. After decimal point, the number is not terminated. Whereas here it's terminated. So the rational numbers are terminating and non-terminating but repeating. You can find here that 2 is been repeated. So we are keeping a bar here which indicates that 2 is repeated and only 2 is repeated. Okay. And now see here, one more example we'll see so that you will have a clarity. Okay. For example, 0.6 bar is there. It is nothing but 0.666 so on. Okay. And suppose 1.4 bar is there, which is nothing but 1.444 so on. If it is 0.235 whole bar, it will be how? 235, 235, 235. So the pattern is getting repeated. Okay. So these all are non-terminating, means they are not stopping, they are continuing. So non-terminating but repeating. Here you can see it's repeating. Okay, repeating or certain they say recurring also. So in a nutshell, we can say that rational numbers are terminating and non-terminating repeating. There are also some non-terminating decimals which does not repeat, which does not follow any pattern. So those are nothing but non-terminating, non-repeating. Okay, what are those? They are nothing but our irrational numbers. They are also non-terminating, but they are not repeating also. Non-repeating. Got it? Rational numbers are non-terminating but repeating. You can see the pattern is repeated, but here it's not repeated. For example, we all know the value of root 2. What is the value of root 2? 1.414213 so on. And root 3 is 1.732050 so on. And the value of pi, which is the famous value, we all know that 3.1415 something 9265 so on. Okay, here you can observe that after decimal neither it is terminating nor it is repeating. So this is irrational number. So irrational numbers are non-terminating. They are not stopping, non-terminating. Here this indicates it's not stopping, it's continuing. Okay, they are non-terminating and they are not repeating also. You cannot see any factor which has been repeated, a number which has been repeated. Okay. So, and also the square root of prime numbers are irrational. For example, prime number root 2, root 3, root 5, root 7, root 11. These all are prime numbers and these all are irrational. Not only square root of prime numbers, numbers which does not have perfect square are also irrational. For example, root 6, root 8. They are not perfect square. Whereas root 4 is perfect. Right? We get the answer as 2. So it is rational. Okay. But root 6, root 8 are irrational, which are not having perfect square. But remember one thing, square roots of prime numbers are every time irrational. Prime numbers, if you find prime numbers in square root, then definitely it will be irrational. Okay. Even logarithms. Okay. Even you can say that logarithms of prime with prime base are irrational. For example, logarithm 3 to the base 2, logarithm 5 to the base 2, logarithm 7 to the base 3. These are all also irrational numbers. Okay. Even sum of rational number plus irrational number is also irrational. Product of rational and irrational is also irrational. What is I mean to say that any operation between rational and irrational will always result in irrational number only. Okay. So finally I summarize rational and irrational number as which can be expressed in P by Q form, and are rational numbers which cannot be expressed in P by Q form are irrational numbers. Okay. And they are expressed as fractions and they are not expressed as fraction, and they are perfect squares and they are surds. What are surds? Surds are nothing but the square root that cannot be simplified into whole number or which are not having any perfect square. Finally, I will conclude that my topic of rational number as they are terminating. Rational numbers are terminating, non-terminating and repeating. Whereas irrational numbers are non-terminating, they don't terminate, they goes on and they don't repeat, non-terminate, not non-repeating. Okay, now you got a clarity about rational numbers and irrational numbers. Okay, now let's go back to our question. So by looking at the question, within a second, we can say that the answer is which option? Fourth option. Why? Because there is a bar. Bar indicates repeating. Just now we learned that root 2 is irrational, pi is irrational, and here also it is non-terminating, but also any repetition. Can you find any repetition? No, there is no pattern which has been repeated. So these three are irrational numbers and our answer is 1.36 bar, which is nothing but 1.36, 36, 36, so on. It means it is non-terminating and repeating. The second question is from logarithm, which is again very simple and easy. Okay. So the value of 2 log 10 minus log 4 minus log 25 is, option is 1 is 0, option 2 is 1, option 3 10, option 4 is 100. So here we have to follow some logarithmic rules. If you follow those rules, you can get the answer. Okay. Here for now I have written 3 logarithmic rules which we are going to use here. Okay. Identity rule, log b to the base b is 1. The second rule is product rule. Log mn to the base b is log m to the base b plus log n to the base b. Okay, this is the product rule. Okay, power rule, log m to the base b to the power x is x log m to the base b. So these are the 3 rules. You must be clear regarding the rules. Now see here, 2 log 10 minus log 4 log 25. Here no bases are not there, right? If nothing is there, we must assume that it is 10 only. Generally it will be to the base 10 only. Okay, so log 10 to the base 10, which rule? Identity rule. So its value is how much? 1. So 2 into 1 minus, here let us take minus as common. Okay, log 4 to the base 10 minus plus, because we are taking minus as common. Minus into plus is minus, right? Log 25 to the base 10. Okay, this is now what? Log m to the log m plus log n. Log m plus log n. What is it? Log mn. So 2 ones are 2 minus log m plus log n is, we have to multiply m and n. So log 4 into 25 to the base 10. So 2 minus 425 is 100. Log 100 to the base 10. Can you write log 100 as 10 square? Yes, you can write. Now what rule can be applied? Power rule. Log m to the power x. Log m to the power x is how much? X log m. So 2 minus 2 log 10 to the base 10. But log 10 to the base 10 is 1. So 2 minus 2 into 1, which is nothing but 2 minus 2, which is equal to 0. Got it? It's very simple. I have written in many steps, but if you are fast enough, you can skip many steps. Like directly you can write 4 into 25 is 100 and 100 is nothing but 10 square. So to make you understand, I have written in step by step. But if you are perfect enough and if you have practiced well, you can skip many steps and you can solve the answer very soon. Okay, next.